Let's talk in this video about the physiology of the vision. And the first thing we will talk about, or actually just to remind you about, was the light pathway and the signal pathway through the eye. So we said for the light passes through the cornea, aqueous humor of the anterior segment, lens, vitreous humor, then the entire layer of the retina to the photoreceptors. And then from there, photoreceptors will induce action potential to the bipolar, to the ganglion cell, then optic nerve, and then to the brain. So now for the light, when it comes to the eye, there are three areas where the light gets refracted or bent. When it enters the cornea, this is one. When it enters the lens, this is two. And then when it leaves the lens. Remember, the function of the lens is to reflect the light on the photoreceptors or reflect the light on the retina, so the photoreceptors will get stimulated. The first mechanism, or the first thing we need to understand with the physiology of the eye, is the adaptation for distant vision and for close. Now for the distant vision, our eyes are perfectly fine if we are looking at objects that are around 20 feet or more from us. So for that distance, we do not need any adaptation. The eyes will be perfectly fine, relaxed, and that would reflect the light directly on the retina. Now, for the distant vision, usually it's a sympathetic response. For a distant vision, it's a sympathetic response. However, you need to be careful that this sympathetic response will cause relaxation in the ciliary muscles. And this relaxation would lead to tightening the suspensory ligament. For the close vision, there are two adaptations. The first one is related to the ciliary muscles and the suspensory ligament. For the close vision, we're talking about parasympathetic response. This parasympathetic response will contract the ciliary muscles. So those ciliary muscles will contract and therefore they will get to shrink in their size, and that will cause the suspensory ligament to get loose, and this would allow the lens to bulge, to restore their shape. And therefore, again, if the light is coming from, or we are looking at close object, the lens will be able to correct or refract the light to the retina. So this is the first accommodation for the close vision. The second adaptation for close vision, that the eyeballs will turn toward inside. And as much closer we are getting to the object, or the object getting to us, our eyes will turn more inside medially. And for some people, sometimes their eyes will get stuck or locked inside, so they will be looking at toward the midline of the body. You can do this if you are moving your finger close into your eyes and focusing on it, and you will feel that the two eyeballs are moving toward the middle of your field vision. So the degree of this movement toward the inside is, increased as the object is close to us or getting closer to us. So as you can see here, the degree is not as, or the eyeballs are not turning inside as much as those two eyeballs. Now to understand, let me go back to here. To understand this lens accommodation through the parasympathetic and the sympathetic, I need you to think of a rubber band. So we know for the muscles, when they relax, they extend their size, and when they contract, they shrink in their size. So now, if my fingers, or if those muscles are relaxed, we said they will increase in size. So they will take more space. And see what happened to the rubber band. It became more tense, right? So if the lens is inside in the area between my fingers or hanging in the center, so it will get stretched. If the muscles contract, we said they are going to shrink in size. And see what happened to the rubber band. It became loose. This allows the lens to bulge back and restore its shape. So adaptation for distant vision and close vision is basically either stretching the suspensory ligament, and this will happen when the muscles relax, and this is sympathetic response. So the muscles relax, which means that they will increase in their size, and that will put some stretch on the suspensory ligament. Therefore, it will stretch the lens. Whereas when there is a parasympathetic response, those muscles would constrict, which makes the suspensory ligaments loose, and this means that the lens will bulge. Okay, so after understanding those two adaptations for looking for distant and close visions, we need also to understand that sometimes, or that with age, our lens will lose their ability to change their shape so the light would fall on the retina. Therefore, we will have the vision problem. We have the first type is the myopia or the nearsightedness. So in this case, that those people are capable of looking at close objects, but they cannot see far objects. And in this case, their vision will be corrected by concave lens. So that's where the glasses will come in. Then we have the hyperopia, that the far-sightedness, that those people are capable of looking at far objects, but are not okay with looking at close objects. This will be corrected by the concave visions. The third type of vision problem is the astigmatism. And in this case, what's happening is either the cornea or the lens, they will have unequal curvatures. What does this mean? It means that the lens, it's basically layers of fibers, right? And those fibers should be equally curved. So the distance between those fibers is the same. The degree of bending is the same. However, with astigmatism, that you might find that in one area they are bending more than another area, or the distance in one area is not as in the other area. So either it's bending more or the distance between them is not the same, which means that the light, when passes through those layers, it will not reflect or it will not bend with the same degree. So those people will see vision, but sometimes in certain areas it's blurry in their field vision. So if they are looking at, for example, the TV, in one area of the TV it's blurry, whereas in other area it's like perfectly sharp, like maybe there is one person or something. Okay, but one area is blurry. Sometimes that's in the center of the field vision, sometimes on the side of the field vision. So it depends on where those unequal curvatures are happening or occurring. Now, usually there is the vision check, that when we go to the ophthalmologist to check our vision. And usually we will look at thin line chart. And in this chart, as you can see, we have letters with various sizes, and we have those two numbers. So to understand those two numbers, we need to think of that situation in the clinic. The first number is the 20, is where the patient is, patient position from chart. So if this is the patient standing, the patient will stand 20 feet from the chart, okay, 20 feet. So this is the first number, 20 feet. And this is fixed. So that's why it's always 20, 20, 20, 20, 20. Then the other number is the distance needed by healthy individual or an individual with healthy eye to see the letter. What does this mean? It means that the person with a healthy eye can see this letter E from 20 feet. Here, it means the 100. It means that the person with healthy eye should be able to see those two letters, the FMP, from 100 feet, and so on. At the 40, it means that the person with a healthy eye should be able to see those letters from 40 feet. So if the patient comes out and they cannot see those letters, even if they are standing at 20 feet, it means that their vision is 20/40, right? So this means that they need to stand at 20 feet in order to see what a person with healthy eye would see at 40 feet. Same thing here. If they cannot see this line, it means they cannot see at 20 feet what a healthy individual would be able to see from 30 feet, and so on. If it's 20/20, it means they have perfect eyes, right? But if 20/25, it means they have a slight degree of nearsightedness. That it means they need to get closer in order to see the far objects. So a healthy individual should be standing at 25 feet and be able to read this line. Now, I need you to think of the 20/15 and the 20/10, for example. What does it mean? It means this person can see from 20 feet what a healthy person can see from only 15 feet. Or this person can see from 20 feet what a healthy person would see from 10 feet. I'll stop here, and in the following video, we will talk about the photoreceptor physiology.